All right. Welcome to Forward Future Live. We are back from the holiday, from the new year. Welcome back. It is Friday, January 9th, 2026. And again, with me, I have my co host, Nick Wentz. Welcome, Nick.
Hello, hello. Good to be here.
And we do have another amazing show, another amazing set of guests. Let me tell you about them. First up, Ioannis from Reflection AI, co-founder, CTO, and president. Somebody who was working at Google DeepMind, Alpha. He worked on AlphaGo. He was kind of at the special moments in AI history, and we get to talk to him today. We have Sam Schillace, CVP, Deputy CTO of Microsoft, also the creator of Google Docs, and he's here to talk about the future of productivity, the future of our interaction with agents, the future of work. Very exciting. And then, of course, bringing back Andrew Feldman, founder and CEO of Cerebras, to talk about the shift from training to inference, chip speed, custom chips, and everything in between. And Nick, let's talk about a few things before we get into those.
Yeah. Well, first of all, going to be a great show. Going to be fun to talk to Andrew again. Let's see. We were in Oklahoma City in, gosh, was it October?
Yep, we got a really awesome tour of their brand new facility, their brand new data center. They had just launched it, just opened it up, saw like three of the most incredible giant generators, diesel generators. I think it was like three of the four biggest in the entire state were
Yeah.
located in that facility.
Yeah. And so, yeah, we'll have to talk to him about it directly. But I remember distinctly the battery room, which is probably I don't know, at least 100 feet by 100 feet room,
Yeah.
and it's just filled with batteries. So for that instance when power goes out, those batteries can kick on before the generators turn on, which only takes like 10 seconds, right? And
Yeah,
that's their sole purpose.
exactly. So super interesting, really cool. Excited to have him back. Obviously, we're going to be talking about the Grok acquisition with Nvidia and all the Nvidia stuff, and obviously everything with Cerebras. So very excited to have him on.
Before we get into stories, how was break? You know, this is our first show back from break.
Yeah, it was good, and I just got back from CES earlier this week. My second year at CES. Nvidia invited us. That was cool. Got to see a bunch of cool stuff from Nvidia. I didn't actually step foot on the show floor. I think I was a little bit bored last year on the show floor, to be honest. It was there was some like decently cool stuff, but nothing mind-blowing, nothing groundbreaking that I haven't seen. There is something that I discovered this year. Apparently, the right way to do CES is to get invited to all the private events. Essentially, all the biggest companies kind of buy out the hotels, buy out the conferences in those hotels, not on the main CES floor. You get invited to them. They show you these that, you know, their private cutting edge stuff. That's what Nvidia did for us, but apparently all the companies do that, and now we know for next year.
Gotta know the tricks.
Yeah, so it was cool. It was good. How about you?
Break was good. You know, it's weird when we are talking about what's happening in the industry, talking about the developments every single day, to have kind of a lull. You know, not a lot happened in between Christmas and New Year's, and it's weird. My life feels untethered in those moments. And so it's good to be back in the swing of things. You know, there's a lot happening in AI right now and tech in general, and we're going to get into all of it today.
Yeah, with the brief exception of the Grok acquisition on Christmas Eve. So
Right.
that was interesting, to say the
Indeed.
least. And I'm still trying to find out what's going to happen with my shares.
They're not getting back to you on that. Yeah.
You know, they're probably working
Might
it out somehow.
might be a little busy. Yeah, it will be interesting to get Andrew's perspective on that one.
Yeah.
All right, well, let's talk about the first story now. This came out um earlier this week. I think it was, yeah, January 8th. So actually just yesterday. But Nvidia comes out with Alpamayo,
Yeah.
and this is open source autonomous driving stack.
Delicious.
Uh, yeah, created some ripples. A lot of people had some reactions to this. What was yours?
Yeah, I saw it live. I saw him make the announcement live. I was at the Jensen keynote in Vegas CES. Super interesting. I think there's a lot of things here. One, completely open source, open weights. They're basically saying, hey, just take what we've built and go build autonomous vehicles. I think also interesting is if you look at Tesla and you look at Waymo, the two kind of shining examples of successful autonomous vehicle companies, they both have millions of miles of driving data. Nvidia does not. Nvidia doesn't even have a car. So how could they collect all of those miles? And so apparently they only used 1,700 hours of driving data video, but it's almost entirely synthetic, which is super interesting because if they have actually unlocked autonomous driving using synthetic data and a low number of miles, that could be huge. That could allow the entire industry, outside of Tesla and Waymo, to catch up and to actually have true autonomous vehicles. They showed off their partnership with Mercedes. They had a Mercedes driving around San Francisco. It looked quite successful, but of course, it's just a demo video. We won't know until people start using it and talking about it publicly. But it's interesting. You know, I still have some doubts that the legacy auto manufacturers are going to be able to get out of their own way, because they haven't to this point. They're incredible at making vehicles that drive really well and feel good driving, but they don't know how to make computers. And vehicles have essentially become computers on wheels.
Yeah. Super interesting indeed. I mean, if you think about, and I'm by no means an expert in this area, but broad strokes, if you think about the phases of this kind of technology, early days of this kind of transformation in self-driving, you have basically the Waymo approach, using LiDAR heavily, using radar, cameras, HD maps, all of this stuff that goes into making this work. And then obviously tens of thousands, hundreds of thousands of hours of training data.
Yeah.
And then, you take the Tesla self-driving approach, and that looks a little different. That's camera-only systems, right? So it's a little bit more sophisticated, perhaps. And that wasn't possible until AI started making progress, right? And now we're talking about a kind of a new shift completely where, to your point, you're using synthetic data. And so what appeared to be a really strong moat, building up those thousands of hours of training data, like, is no longer a moat. And it becomes
Possibly.
much more accessible.
Yeah, Nick, such a good call out. I didn't even mention that. Yeah. So like what is like super special about Alpamayo is it seems to be almost primarily vision based, which is the technique or the approach that Tesla took. They say, okay, if humans can drive cars with just two eyes and nothing else, we don't have radar, LiDAR, we don't have all these extra sensors, then why can't AI do that? And so they being Tesla made this huge bet, and it seems like Nvidia took the same approach. I believe that it does support LiDAR, radar, but primarily it is vision based as opposed to Waymo, which is LiDAR, radar, vision, everything. Those cars, those Waymos, are much more expensive. And so it allows legacy auto manufacturers to actually implement autonomous driving, if they can get out of their own way, for relatively inexpensively as compared to if they had to add LiDAR. Now, if you think about, there's kind of two examples of auto manufacturers that have been adding LiDAR. One is Volvo, right? Volvo, the kind of the high end, latest generation models have LiDAR in them. And recently, Rivian announced it is adding LiDAR to their future vehicles. So it's going to be interesting to see how this plays out and which approach works best. In my mind, I kind of agree with Elon. If humans can do it, end-to-end neural networks with just vision should be able to do it.
Yeah. And I think we should talk about the broader implications of this. Actually, Joan on our team brought this up, but if you open source this technology, theoretically, other car manufacturers are going to get on board, and that means that we go from a small percentage of self-driving cars to a large percentage of self-driving cars, and so you start seeing the benefits of that play out in a more significant way. Climate change reduction, or emissions reduction, at least. You start seeing less accidents, less fatalities. You start seeing less traffic, theoretically, as well. And so that's pretty exciting to imagine.
Yeah, I was driving to the airport to CES, and I was going with my friend, and he was mentioning like, hey, there's probably a huge benefit of these vehicles talking to each other. And he was just talking about, we were driving in a Tesla. Tesla's talking to other Teslas during autonomous driving, but I don't believe they do. But really, to kind of maximize the benefit of autonomous vehicles, it would be great if they could all talk to each other.
Right.
And so yeah, that they're not necessarily being super defensive on the road as they probably would be. Yeah, our guest is here. Maybe we bring him on in a minute.
Yeah, let's do it. Let me just read this tweet very quickly by Rains. It's just an interesting perspective on what we're talking about here. So I have to admit that I feel a bit worried when I saw Nvidia release Alpha Mayo. It is, in my opinion, the first real competitor to FSD, full self-driving. First of all, it does not rely on LiDAR, which is already impressive and better than all other losers out there. Then the concept of VLA, video learning,
Vision, language,
vision,
action, I think it is. Yeah,
vision language model, and then VLA is vision language action, I believe, is my exact understanding of what FSD 14.3 would be. And I believe NVIDIA is doing really well at training general purpose, small size VLMs. So I don't think it is very obvious who will train the better VLM for driving between NVIDIA and Tesla. I'd guess Tesla, but blah, blah, blah. So this goes on. And then, of course, Elon Musk chimes in, I'm not losing any sleep over this. And I genuinely hope they succeed.
Yeah,
so
Jensen and Elon seem to have, at least publicly, an optimistic relationship about each other, which is, maybe
they're cordial.
Not common for Elon. He's usually pretty competitive and negative towards his competitors.
There's some mutual respect there for sure.
Yeah, and by the way, one last thing on this. I mentioned I drove to the airport in a Tesla. Someone picked me up from my house, my friend. It was raining. I live on like a very small, windy, one-lane street that has two-way traffic. And like it was just flawless. It was nearly an hour drive, freeways, airport, parked itself. I mean, I was so blown away by it. I hadn't driven in a Tesla with autonomous driving in a while. And so I was beyond impressed, and it really makes me just believe in the vision only approach.
Yeah, my experiences have also been very positive. I know, again, Jonah swears by it. I think he exclusively uses it.
Yeah, he says he doesn't drive.
Yeah.
Yeah.
All right. Well, let's bring on our first guest.
Cool.
So, and that is Ioannis Antonoglou, the co-founder and CTO and president of Reflection AI, which recently raised $2 billion to be America's open frontier lab, positioning itself against closed labs like OpenAI and Anthropic, and of course, China's DeepSeek. Ioannis, welcome to the show.
Good to be here. Nice to see you both.
Yeah. So, there's so much to get into. I want to start, and this is because I actually watched The Thinking Game last night, I have to admit. Really enjoyed that, by the way.
I watched it about a week ago.
Yeah. So there's a lot to unpack there, obviously. We'll get into your company as well. But just to start off, you've been at the center of AI for most of your career. And so going back to DeepMind from the very beginning and building these systems like AlphaGo and AlphaZero. And, during The Thinking Game, Demis says something fairly early on. And it was that AI wasn't exactly a respected field when DeepMind was started. If you told someone you were working on AI or an AI researcher, you weren't exactly taken seriously as a scientist. And now, look at what's happened today, and it's a complete transformation. And so I guess the question here is what surprises you most about how things have changed in regards to AI and the sentiment that people have for it?
Yeah, actually, this is I also saw the Thinking Game, and it was going down the memory lane for me. It kind of reminded me of the early steps of AI, and when I joined DeepMind in 2012. It was the company was 25 people back then, and it was a completely different kind of mentality that we had towards AI. It felt extremely ambitious. I think like even more ambitious than it feels now. It was a dream, and back then it attracted people who are like dreamers and who really wanted to kind of push hard and just like build something. Um, and kind of like looking back then, it kind of like reminds me how fast like the field has actually moved in the past 15 years. And I remember like when AlphaGo came out, it was actually like a few weeks before we published the paper. The consensus was that beating a professional in the game of Go was a decade away. And literally like weeks after that, we actually released AlphaGo. And I just kind of like see the same pattern of like people feeling that AI is like really far into the future, or like no, we won't get there, or like maybe we've actually like hit a wall, or like we're slowing down. And then you just like see that the same methods just like keep giving, and just like keep kind of like pushing us like further closer into really powerful intelligent systems. So it's like really moving fast, and the progress that we've actually made in the past 15 years is it's crazy. And yeah.
So talk a little bit about those systems that you're saying continue to give. What systems are you referring to?
So we're actually like building these powerful general models, doing pre-training, doing reinforcement learning at scale. And we actually like see that as we scale these systems and we use more compute, we use more data, we do reinforcement learning at scale, the systems just like continue to improve. And you have like agents that can solve math problems now at like at the level of like the most powerful mathematicians. You have like agents that can actually solve and can write and produce software that like takes hours for like humans to do that, and they can coordinate between them. So the fact that we are at a place where these things, if I asked anyone in the field 5-6 years ago that like we will have agents that can run that can write whole piece of software like end to end, they think that like I'm crazy. They'll say that like, no, this is not happening, like at least 30 years away from that. And now it's kind of like, yeah, but sometimes we'll make mistakes. That's kind of like how much the debate has shifted. And no, it's insane how fast things are moving.
And so do you think that we're not hitting a wall on the scaling side, specifically on training, or like where do you think we still have massive gains? Is it at every piece of the process?
Yeah, I mean, I think that like there's still room for improvements across the whole stack, and it's we need like more compute, and more compute can actually like continue to give like more gains. And this is actually like the story of AI for the past 15 years. That like it's ideas, of course, but like compute has been a massive driver in improving the capabilities of models.
In those early days when you were working on AlphaGo, I'm curious if you could actually just explain in simple terms what were the steps to the specific steps that like led to these breakthroughs. Was it really just the reward system? Was it something as simple as just reinforcing the learning that it was doing? But can you just provide like a simple explanation of what exactly was going into that?
Yeah, so one thing that I find really interesting is that the recipe that we used for AlphaGo was actually like quite similar to the recipe that we use today to actually build these powerful models. Like there are many parallels that you can draw between the different systems. So like the way we trained AlphaGo was first we took many games that like human professionals had played with each other, and we tried to build a system that can imitate, or like it can predict the move that a human professional would take at a particular board position. It's kind of like similar to what we do now with pre-training. So when you take a model and you train it on all of the human knowledge on the internet, you're kind of like trying to teach the model to imitate the thinking processes that go into the way that like humans generate text, or like they reason, or they think about stuff. Now, once we actually had that, then we used reinforcement learning to actually train the system by having it play against itself. So we did a form of self-play. We used that to build a value function. And what a value function was, is actually like a way to evaluate the position and to just like give you a number that like tells you how good the position is. So if it's closer to 1, that's like a really kind of like winning position for you. If it's closer to 0, it's a losing position for you. And then if you actually have a system that can predict the positions that human professionals would take, and then you also had a value function that was trained on games that the system played against itself, then you can actually like try and look forward and just like see what moves make more sense versus like less sense.
And Ioannis, I want to talk about the self-play piece for a bit, because it just seems like that's really good if you have the verifiable rewards, if you have a value function. But what about in fields that don't have that? Creative writing is just like the kind of easy example.
Yeah. So what we used to do, like, and to some extent we still do, is that we use humans to just provide this reward, and it's kind of like what for systems that like you don't have like for Go, you can always just like play the game and see who wins, right? Like, and then you get like a verified reward, like whether like you actually end up winning the game or you lost the game. For things like creative writing, it's more about providing 2 answers to a human or like a really powerful model, and then ask the model what it thinks, or like the human what it thinks, and which one it prefers. And so like you still have like a reward, you still you have like a something that you can reinforce the behavior of the model, but then instead of just being objective, it becomes more subjective. That's kind of like the main difference. But I'd say that like I'd argue that like this is also how humans learn, right? Like how do you know that the piece of essay that you wrote is actually like a good one or a bad one? Based on like the feedback that you receive from other people. So this is kind of like similarly how we train these models. And these methods are called RLHF, so reinforcement learning from human feedback, or RLIAF, which means reinforcement learning from AI feedback. So like the AI judges, like one AI judges the outputs of a different AI.
Will verticals that don't have verifiable rewards ever be able to scale as large or as quickly as ones that do? And so I think like when you look at code, which has been completely revolutionized by generative AI, it's very obvious because you can run the code, you can see if it works, and then you can just continue to iterate. But again, like creative writing or image generation, you don't have that. Is coding always going to be at the forefront, or other verifiable categories?
So the thing about like there's a thing called reward hacking, and what reward hacking means is that if you train an AI to judge the output of a different AI, then the one AI can always just like start producing outputs that fool the judge AI. Like the judge AI has like some kind of like blind spots, and if you just like push it towards like these blind spots, then you just like find biases in its thinking that like actually maybe it prefers like longer outputs, or like it prefers like bullet points or whatever it is, and then the system optimizes for those. And these biases even exist with like humans. So like humans, it's interesting that sometimes we prefer longer responses or like shorter responses, or like we prefer like certain structure over like a different structure when we provide the reward. But like when we have like maybe more of a kind of like normal use, we don't really care as much, or like we don't have like the same biases. So there are always biases. These systems are like really powerful. They'll always just like go and uncover these biases. So in that sense, when you have like something that's more objective, it's easier to like really fully optimize it. Now the question then becomes, what does it really mean to just kind of like you can tell whether a piece of software is much better than the previous one because it actually solved the problem that you couldn't solve before. For problems like creative writing, it's also like unclear what the reward is, right? Like, what does it mean that you're like much better at creative writing than like a previous system? Like, there's a lot of subjectivity to it. So I think it's like also a way. It's like the difficulty of measuring the absolute performance of a system. And when you have a verified reward, you can actually also evaluate it better. So like there's almost an objective way to say that like this AI is significantly better than a different AI because like you can actually measure it and there's like a number associated with it. And this is also like true for board games, right? For chess or Go, you have like elo scales, which actually tell you whether one system is like significantly better. There's like a binary event, who won the game, right? Like, and then you can use that to know which system is better, which is not really the case with like things that don't have like a clear reward.
So I want to talk a little bit about reflection AI. But to start that conversation off, I'm curious how your experience with RLHF, and I believe you were on the team at Gemini that helped implement that. Is that right?
Yeah, I was leading RLHF in Gemini 1.0.
Okay, so yeah, I'm curious how that experience, then your experience at DeepMind with AlphaGo and AlphaZero, kind of led you down the path to create this company, and what kind of learnings you're applying at Reflection AI.
Yeah, so we started Reflection AI in spring of 2024, and back then it was kind of it was a different world. I think that like most people felt that the only thing that you needed was to scale pre-training, more computer, more data for pre-training, and then that would just like solve AI. And I had previously spent 11 years at DeepMind doing a lot of the deep reinforcement learning research that happened at DeepMind from DQN, which is the first reinforcement learning agent to ever exist, to AlphaGo, AlphaZero, NewZero, and so on and so forth. So I really believed that reinforcement learning is a big part of the AGI puzzle, and we kind of like set out with Misha to really kind of like show that pre-training is really important, but like reinforcement learning is like the next frontier. And I think like this is something that we see that with Reflection, but also more generally that like there's a lot of focus on reinforcement learning and scaling reinforcement learning. So my bet, like from the beginning, and it continues to stand, is that reinforcement learning is, when scaled and when pushed, it is the family of like algorithms that will ensure that we actually get closer to the ultimate goal of really autonomous agents.
And actually, I want to just rewind for a second. We had Misha on the show a few weeks ago. How did you meet Misha? How did you get connected with him and decide to start this company?
Yeah, that's a great question. So as I said, I was leading RLHF for Gemini, and a big part of RLHF is building reward models. So I was like looking for someone to come into the team and kind of like lead the effort of reward models. So I reached out to an old friend of mine called Vlad Mni. Vlad Mni is actually the first author of DQN, and he's a legend in deep reinforcement learning. And he just suggested that I talk to Misha. So I talked to Misha. He joined my team. He led the effort of like the verifiers and the reward model build out. And we worked really closely and nicely together. So we decided to start Reflection.
Okay, and so you raised a bunch of money, and you're currently creating open source artificial intelligence, open source US based artificial intelligence. Talk a little bit about the decision to make it open source, why that's important to you, especially with your roots from DeepMind.
Yes. So the models, we call them open weight in the sense that we will just make them available. But like open source usually means that everything is available. Open weight is explicitly to say that like the models will be like widely available for research and use more widely. So there are like two things. First, AI used to be open. This is actually what brought us here. Like the fact that we could exchange ideas in the open. There were like many conferences that like everyone will just like come to and really kind of exchange ideas and ensure that like the best ideas survive, and we build on top of them, and we really speed up the progress of AI. And since I guess ChatGPT, that hasn't been the case, at least in the West. And we want to change that because we think that this is actually the way to ensure that like we like progress happens and we actually get to AI. The other reason is democratizing access to the most powerful technology in the world. I think that like AI is probably the most powerful technology that like humanity will ever build almost, and it needs to be democratized and given access to like to the wider world. And finally, the same happened. What happened with the internet is that the internet was built on top of open protocols, open source. it kind of like defines the infrastructure layer. And there's going to be like open models. We see that like there are many open models coming out of China, and there isn't one coming out of the US or like the West more broadly, which means that the infrastructure of the future won't be built here. It will be built somewhere else. And we think that there should be a solution coming out of the US and the Western world more broadly.
How far behind do you think open source is to closed source currently? It seems like that gap is closing, but I wanted to get your perspective on that. And then what do you think in terms of timing before we see like truly like competitive open source, closed source, and all of it flourishing at the same time?
Yeah, so I think like currently the open weight frontier is like maybe 6 months to a year behind the closed weight frontier. And
why do you think that is? Is that a function of funding?
The open weight frontier is currently kind of shaped by Chinese labs. The Chinese labs, they don't have access to the compute, and the people that the Western labs have access to. So it just like takes some time for them to build out their own ecosystem and potentially catch up with the Western ecosystem. There hasn't been like a really world-class team building open weight frontier models in the West before Reflection. I think we are the first ones to really kind of have the resources and the right talent to actually like go for it and build something meaningful. So I felt like this is why. I believe it's not going to be long. Maybe in the next like year or like 2 years, the open and the closed frontiers will just kind of be almost at the same level of performance. This is kind of my timeline.
When can we expect your model?
2026 is going to be a really interesting year for the open weight frontier in the West. Is what I can say.
Fantastic. So I'm curious to get your perspective on why labs seem to start open and then go closed. Is that for commercial reasons or other reasons? There's kind of a this common refrain where you go open to catch up to the frontier, right? And then once you've done it, you kind of close everything down.
Meta is a good example.
Yeah. So yeah, exactly.
Yeah.
What are your thoughts on that?
I feel like it's case by case, really. I feel like Meta is the company which did that. Like they started open and now they're closing. And if you want to have a frontier lab that continues to build frontier models, you need to ensure that like the commercialization of these models also is aligned with the strategy of open source. And for Meta, they're more of they're a consumer company. That's what they care about. So it didn't really like it was kind of like orthogonal to their strategy, which is eventually what led to closing their models. So it is important, and this is something that we are doing at Reflection to ensure that your commercialization strategy and the way that you can commercialize these models, so you can continue to fund your research, is fully aligned with an open weight strategy.
And talk a little bit about commercializing open source. I think there's like some tried and true examples over the years where you're talking about Linux and security systems. Like, how do you envision specifically a Reflection commercializing your AI?
So there's a lot of thinking that has actually gone into our commercialization, and it's like more broadly ensuring that the open models the open frontier models actually power and cover the needs of big enterprises and sovereign states.
Are you planning on serving your own inference? I assume you are. Are you just providing services on top? Can you share a little bit more detail?
Yeah, we'll actually like also be providing endpoints for our models. This is the way we see it is going to be the first, the easiest way for people to try our models and see how capable they are. And of course, like we're working with partners, and there are like many things in the works that like I cannot really share at this point. on how these models would be like widely available and accessible.
Just speaking more broadly about adoption in the enterprise, seems like I mean, of course, there's the infamous MIT study that came out last year that says, most enterprise rollouts fail. Curious why you think that is, and then also, what are you all doing at Reflection that you believe you'll be able to kind of overcome that stat? I think it was 10%, or only 10% are successful. So what needs to happen to make adoption more widespread in the enterprise?
I think what's happening here is that there's almost a mismatch between what the enterprises on their own can actually do with this technology and what this technology can do. And there's like a gap in skill set between taking what's possible with this technology, and ensuring that it provides final value to the enterprises. So it is possible that it is important that like you provide a solution almost end-to-end, that you just like go and work with the enterprises to ensure that you provide the know-how on how to build these end-to-end solutions and help them really adopt the technology. You cannot just like give them an API or just like give them a model and just like say, go figure it out.
So yeah, I mean, I tend to agree with you. I hate to say it, but it's almost like a skill issue or a culture issue. They're just, especially, like an enterprise company who doesn't have deep tech background, they're trying to roll something out. They think, hey, if it didn't work the first time, it probably won't work at all. Instead of making a lot of small bets, seeing what works, iterating on that, and building a culture around deploying artificial intelligence internally. Is that kind of what you're speaking to?
Yeah, exactly. So like you need, this is a really new technology, and it's like a really involved and complicated technology. And if an enterprise is that like have like really strong technical backgrounds, they haven't really caught up with like the latest in the AI developments necessarily. So this is what we do. Like we spend all our days like thinking about AI, building AI. We have like a lot of know-how. We know how to deploy the systems, how to build the systems, what are the capabilities of this system. So it's important for like the AI providers to also go and help enterprises to understand how to use these systems and how to make the most out of these systems.
And when you look at open versus closed source, I want to go back to that for a moment. Talk about the security and the safety risks of open versus closed. Is there increased inherent risk when kind of a handful of people inside of a handful of companies have all the research, or not all the research, but kind of are kind of closed off from the rest of the research community? Do you see that as a problem?
Yeah, I think that like it's important that. Yeah, there are like there are two arguments. Like one is that if we have a restricted number of labs that have access to intelligence, then we can control it better. I disagree. I think that having more people who can work on doing research on these models, uncover their blind spots, really kind of ensure that we kind of like debug it almost like collectively with the research community. It's actually like it leads to safer and better models. And there's a precedent with open software, that like open software, because everyone's like looking into it and everyone's building on top of it, they end up in the equilibrium being like more robust and like safer to use than like closed models, closed piece of software. So fundamentally, by having open intelligence, it will lead to safer and better intelligence.
Okay, great. Ioannis, thank you so much for joining us today. It's been an absolute pleasure. Please come back anytime. Tell Misha to come back. You guys are always welcome.
Great. Thank you so much for having me.
Thanks for the chat.
Yeah. Have a good day.
All right.
I think I got 80% of the way through the thinking game last night. I'm excited to finish it off this weekend.
Yeah, I mean, you were talking about the kind of the lull of AI announcements and news during the holidays. Obviously, everybody, a lot of people are on break. And then I got to watch the thinking game, and it like I wanted more. I wanted to see more products come out, and it just got that kind of fire in me that I was spending a lot of time with family and kind of relaxing a little bit, but I was like, oh my god, I can't wait to get back now. Like that movie like kind of just lit a fire under my butt a little bit.
Yeah, it's totally inspiring. Are you a big StarCraft player, or were you?
I was terrible, but I loved it.
Yeah, it's such a fun game. I thought it's especially interesting seeing them create systems to play a game like StarCraft, where it's real time in nature, it's
Yeah.
very strategic. And I found it interesting. I think I just got to the point where one of the StarCraft pros, top rated players in the world, actually beat the DeepMind system.
Yeah.
It was just kind of this significant moment where it's like, oh, well, we haven't quite broken through. But then to, hit Giannis's point, you keep applying the reinforcement learning, and eventually it just happens. And you saw that happen when they were using Pong too. It wasn't working, but give it enough time and it eventually learns. So it's just
Quick
interesting
aside,
to see
do
that play
you
out.
remember that, Nick? Sorry to interrupt. Do you remember that portion where Demis talks about his time at Bullfrog, the video game?
Sure.
company?
Yeah.
So they talked about a bunch of different video games, but they left out one of my favorite video games growing up, which is Black and White. And I think it's in like licensing limbo right now. You can't even buy it. But Demis, first of all, at the time, that game was completely novel, very new ideas about how video game interfaces should be. But what that game had was insane artificial intelligence. And for years, I just thought like, wow, they did something special with it. And then a couple of years ago, I found out, no, Demis was working there. He is the one responsible for the AI in that game. And it's so cool to put all these little pieces together. And yeah, man, the folks at DeepMind, incredibly talented. It must have been really special in London during that time.
Oh yeah, the concentration of talent. I don't know.
Just
Unbeatable.
Yeah.
The theme park example was the other one, and Demis was involved in that too, creating those autonomous characters. And I think the example they gave in the thinking game was if you put a food kiosk too close to a really big ride, then you have people throwing up outside of the ride, and then that causes other people to throw up reacting to that. And so then you have to hire all of these like maintenance workers to clean up. And these are like you can just see it playing out.
That's the true mission of AI is throw up intelligence.
That's right. That's where it all started. All right. Well, without further ado, I think we should bring on our next guest.
Yeah, absolutely.
All right. So we have Sam Schillace, CVP and Deputy CTO at Microsoft, where he leads efforts in consumer products and future productivity tools. Now, if you're one of the billions of people who have ever used a Google Doc, you're using Sam's brainchild. He co-founded Writely, an online word processor that was acquired by Google and then became the foundation for Google Docs. Sam, welcome to the show.
Thank you. I still have the very first one, actually, believe it or not.
Your very first doc, Google Doc?
Yeah, the very first Google Doc is in my personal GDocs account. I mean, it's like the first one in the ship of Theseus sense, basically, right? Like the back end has been migrated twice, the front end has been rewritten twice. Like,
so
the NFT of it would be more original than the original thing, but it's still there.
So what's in the doc?
Not much. Like I think we were testing images, so it's got a picture of Edna from The Incredibles, is what's in there right now.
Perfect.
That's so cool. Yeah, of course. Like I have a Google Doc open on my screen right now with the notes for the show. It's just like such an integral portion of what I have done for the last 15 years with my startups. And yeah, it's such a crazy good product. Very impressive.
What is the Google Docs breakthrough? Is it collaboration? Is it sharing? If you could sum it up in a sentence, what do you think it is?
It's users are lazy. Basically, I mean, like it more or less, like you probably don't remember, like back in the day, like the only way you could share a document back then was either a file share or an email, right? And like both of those were kind of crappy. Like if you had a file like a shared file server, people would like open a document and like go home for the weekend, and it would be locked open, and you couldn't do anything with it, or like only one person at a time could use it. So it's like really inconvenient, and so like. That was mostly the breakthrough is like just make it easier. Like the history of it was just, a lot of, just playing with stuff basically is kind of the theme of today too, just playing around with new technology. Like JavaScript had shown up, we knew word processors, so we were playing around with word process. It's just a kind of natural thing to do something with a word processor. Gmail was like the year before, so like we kind of had web apps in the brain. We just sort of started to put it all together, and then like we immediately realized that like collaboration was a problem. Like, if multiple people are in the document, you can't do like last in, like that, it just doesn't work. Like you keep stepping on each other. So like getting it up and running was pretty easy, but then, getting it to be right was just months of pain because the browsers were not ready to deal with it. JavaScript was really crappy at the time. I mean, like, it's kind of funny when people argue about JavaScript frameworks. I'm like, jQuery didn't even exist when I was doing this. Like, I wrote it raw, like, poking at the browser to figure out like what would happen, like that kind of stuff, like 20 years ago.
Was Java the key technology to really unlock the kind of web app version of
JavaScript? Yeah, JavaScript. Like the funny thing, like little known fact is like the server was C# because we were playing around with C# at the time and we thought it was kind of an interesting language.
What year was this, by the way?
2005 was when we started doing it. It's pretty old, like 20 years ago. But the interesting thing, which is maybe relevant to the AI age, is that like it was messy, and it from this perspective, GDocs looks like a really brilliant, obvious idea, right? But like because everybody uses it, it's billions of people. Like it seems it's hard to argue with it. It's like it worked really well. But from like the perspective of 2005, like people thought we were nuts. And like I had like 500,000 users and I was still getting people telling me like it wasn't going to work. Like this is a bad idea. Like JavaScript's a crappy language. What is this like untyped crappy interpreted language shit? That's like vibe coding. Like it was like that exact attitude of like this is never going to work. That's not real code. That's not a real app. And then users were confused, right? Like what is this thing? It's a web page. But it's not a web page, you're editing it, but you're not editing the web page, you're editing a document, but it's actually an application, but it's also the document, and it's not really there, but it's somewhere in the cloud. Like, there's just like a whole bunch of concepts all at once for people to get their heads around, which are obvious to us now, but were very much not obvious then. It's like, it actually was a really good lesson for me to go through that, because we like simultaneously got people who are huge champions, like Nate Torkington over at O'Reilly was like a huge champion really early in the day. But like a lot of people who were like really skeptical. And so like that really like informed how I think of disruptive moments and new technologies and how you have your mindset correct and stuff like that. I actually wrote a book about it.
It's so hard to imagine anyone being skeptical of a Google Doc in this day and age. It's something that's so ubiquitous and we completely take for granted and yet use every single day.
It is. But that's the key insight though. Like in the moment you will be skeptical. And so that's actually the mindset you have to like break through.
Because what are we seeing today that you think we'll look back on and be like, well, how were we skeptical about this thing 20 years from now?
Well, I think the whole like through the last 3 years of generative AI, like I've been talking about this constantly. I wrote a book about this called No Prize for Pessimism, because like there's no prize for being pessimistic and correct. Like who cares, right? You get a gold star if you're pessimistic and write about something. But like I've been seeing this for a long time, and people are like, well, like this AI thing, like it doesn't work right. It hallucinates. It's too expensive. It's too slow. It's not that smart. Look, I found a mistake that it made. I call this like the why not mentality. Like, if you decided you want something to fail, you ask all these why not questions. And the right thing to ask is the what if questions. Like, what if it does work? And like, what if you lean into it and it does work? And like, from where I sit, like you look back, even over like the last 6 months, like the transformation and capabilities in this technology is remarkable. So like I think that's the easy one right now. Like it's kind of, I always view kind of everything through this historical lens, but like definitely all the criticism about generative LLMs, all the AI from like the last 3 years, all that stuff. Like I view it through this historical lens of like, are you is that a real criticism, or is that like you started with the emotion of not wanting it to succeed and you're making up the why not story to make yourself feel better?
Yeah, and Sam, like we're seeing, as you said, like a complete revolution in coding specifically right now. That is the first industry that has been flipped on its head. But we aren't seeing that in other industries yet. And I am an optimist, but I want to hear like why do you think we haven't seen it? Is it just a function that the generative AI wave has been going only for 3 years, or like are there improvements to the models that are necessary, the scaffolding? What do you think?
I mean, like there's a kind of all of it. Like here's other history to kind of remember. GDocs, right? Transformative thing, 2005, right? That was when we did it. When did the browser come out? Do you remember? 93.
Sam, you're cutting out a little bit. Maybe you can lean forward just a little bit.
Oh, I'm sorry. Yeah, I'm sorry. I'm blue. I'm not sure what's going on with my camera. I apologize.
No, you're good now. Sounds good. Yeah,
it's a very complimentary shade on you.
Actually, yeah, I guess I'm not usually this. I'm not actually an Oompa Loompa. No, like GDocs was like 2005, right? So when did the web start? 93. Like the browser was 93. That's a really long time, right? So just looking through historically, first of all, right? Like it hasn't been that long for LLMs, right? 3 years, even though this has been a very busy, very tiring, very fast 3 years, it's still only 3 years. We're still working out a bunch of best practices, tooling, infrastructure, stuff like that. I think with code, I wrote this last week, about coding. Like, code is a little bit easier for the tools to get to, right? It's very language based. The plumbing is really great. Like, GitHub is very easy to access. APIs are very easy to access. File systems are very natural for the models. Programming languages naturally tokenize really well. So, like, code is really easy. Code is going first, I think, for a bunch of those reasons. But you can kind of see the same patterns happening. The tools are getting better. We're starting to understand best practices. Different domains are getting more plumbed in, as you see different things start to happen. I had this really interesting thing. We've been building this agentic thing called Amplifier, which folks can play with. It's up on GitHub under Microsoft's user, Microsoft/Amplifier, which is just an agentic tool like Claude Code, but an open one. And one of the people, like, my team is full of technical and non-technical people. Some of the non-technical people will just do amazing things with it. Like, one of my PMs was on an airplane. He decided he wanted to do a study on how to, like, get statistically significant subagent persona behavior. I'm not sure what he was playing with, but conceived the study, built some code, had Amplifier, like, fire up Mechanical Turk, like, go ask a survey of 50 people, get the data, run the data through his thing, write some further code, produce the bunch of graphs and stuff, and then generate the document, the actual research paper, like, on a flight with crappy Wi-Fi. And so, like, he got in like 4 hours. Like, so he got that to work because, like, the plumbing worked really well. So I think, like, we're supposed to. I do decks all the time now. Like, I just generate HTML pages. I did one that was like in an Apple keynote style yesterday as a joke for my team of, like, how cool Amplifier is. It's like 38 slides of, like, black backgrounds and sexy text and fading in and out and stuff like that. So we're starting to see the plumbing happen, and, like, it's starting to emerge.
It truly is incredible. I was talking to a CEO of an early stage startup earlier in the week, and he was telling me he was on a call with a design partner, essentially a customer, and the customer wanted a feature, and he hopped in Claude Code and started building the feature in real time and getting feedback from the customer as he was building the thing. I mean, that just doesn't happen a year ago.
Somebody at Microsoft, somebody joined recently, and they were like, "Oh, I've got this really ambitious project I want to do." It's like some agent thing, onboarding agent thing. I was like, "Tell me about it." And they gave me the description, and, like, we're talking, and I, like, threw it in an Amplifier section in the background. By the time we were done talking, I had the first version of it up and running. Yeah, so it's really incredible how fast this stuff is. This is, I think, the thing that people don't really understand. And it's really kind of funny to read some of the skepticism right now about how.
Hey, Sam, sorry, we're getting a little feedback on you again.
I'm sorry.
I just want to make sure we can hear what you're saying.
Yeah.
I'll scoot up. I apologize.
Yeah,
But I just think it's really funny to, like, watch this stuff. Watch people, be skeptical and critical of, AI. It's like fake, it's not working, it's a bubble, whatever. I'm like, I can see these, like, elite developer communities producing just crazy amounts of output. Like, we produce crazy amounts of output. My lead engineer not really working very hard on break, with just, like, running in the background, kind of occasionally checking in on his phone, generated 1,200 CLs that are part of the project now. So, like, it's just, I think that people don't really quite understand, like, how effective these tools are getting. And I think the coding community sees it, and it's just barely starting to leak out into other information workers, but I think it'll start to happen.
So when you look at coding specifically and then expanding out to other verticals and categories, do you think that there needs to be more model breakthroughs, more intelligence in the models, or do you think we need to focus more on the scaffolding around it, the tools, the understanding of how to get the most out of the models?
I think there's a little bit of, I think the scaffolding really matters a bunch. Like, my team at Microsoft, like, I have a research team that runs underneath me in the office of the CTO, and that's all we've been focusing on for the last 3 years is AI coding, like building scaffolding around models. We don't train models. We don't even fine tune them. We just use them as is and see what we can get out of them. We've consistently found that we get more leverage out of the model, even as the models are getting better. For, like, the first year or two, we were really worried. We were like, oh, eventually these are going to get so good, we're going to have nothing to add. It'll just be like the model and nothing else. But it seemed to be the case pretty durably that scaffolding adds leverage to the models, no matter how good the models get. So I definitely think there's like a lot of work to be done there. You can see lots of, like the scaffolding is, control planes and best practices and work patterns. We have this thing we call recipes, which is a mixture of code and where the code does some metacognition and the model does the work. And like those, we're building those out a bunch, and you kind of see those patterns starting to emerge more and more, mostly in the coding community, but they're starting to emerge in other places. So like, and that'll just feed back into the model getting better too.
So, Sam, you worked closely with Aaron Levy at Box in the very early days. Yeah. So, friend of the show. I wanted to talk because he is prolific on X, talking about the agent and human relationship, the future of work. So, I want to talk about that a little bit. Do you see this collaboration with humans and agents? How do you see it changing? Do you think humans will always be in the loop? I think Srinivas said that, when you look at an agent, it can go middle to middle, but not necessarily end to end, and humans still need to prompt and verify. Do you believe that? What are some of your thoughts on how humans and agents are going to interact in the future?
Yeah, I think that I believe humans will still be in the loop. It's kind of funny because when people worry about like AI replacing jobs, I kind of laugh. I'm like, man, it'd be kind of nice if it replaced my job because I'm more busy now than I've been. I haven't been writing code for the last decade or something, and now I'm writing code. I've got like 8 amplifier sessions open right now, like in the background of building like 3 different apps and a bunch of different stuff. So like what you find very quickly, at least with the agentic coding. And by the way, like I'm really like skeptical. I hate the word agent. I've hated it for a long time, but what's going on in coding now really feels genuinely like agents to me. So I'm starting to use that language. But what you find is you saturate, like kick it off and it's fine. But like, another one I have going right now is a desktop app that I'm building that's like a collaboration tool. And it spent the night testing it. It thinks it's successful, and I booted it up and it looks okay, but I need to spend like an hour or two just like really to talk to each other, anymore. So it's almost like the 3-person team is really the 30-person team.
At the point of saturation, does that mean that we need to increase automation and maybe the agents need to do more reviewing?
That's what everyone's trying to do. Like we're all working on this kind of different kinds of hierarchy and stuff like that, right? Organization is big enough, all the problems interlock. Like every solution makes a different problem worse. It's like, it's really, really hard thing to have. It's like probably that's what's going to happen actually. Like, well, you'll have these large agentic, fleets that you're working with. They can't all be bugging you because you just don't, there's not enough time in the day to be bugged by all of them. So they have to mostly be independent, but that means when they're not independent, they're stuck on something legitimate, pretty serious. And so like you're going to get, the more work you're doing, the harder the problems that are going to come to you as the manager of this mob of agents, I think. So I think that that's, we'll build those hierarchical tools, but they're, complexity is kind of irreducible at the end of the day.
And we're talking a lot about code, but we asked our previous guest a little bit about non-code areas, and it just seems like we need to help organizations understand how to implement artificial intelligence better. Obviously, engineering organizations are very much at the forefront, and they're kind of eating this up as soon as it comes. But non-engineering organizations may be culturally a little bit afraid of it and don't know how to implement it. Like, what is the solution there?
There's a solution, like that's kind of the broad, change management problem, at scale. But I think that the early answer is like you start to find champions, first of all, right? Like you can't change the whole organization at once. You start to find bits and pieces of the organization that are better, that can optimize themselves. You have to take a system perspective, right? So if you get 90% of the organization to go much faster with AI, but there's some bottleneck somewhere that's doing it the old way, you're not really going to, you can do the math, you're not really improving yourself very much. So, you do have to like have the system perspective of looking for the next bottleneck and figuring out how to unblock that bottleneck one thing at a time, essentially.
Do you think organizations that are, let's say startups, AI native companies that are being formed and understand and build in AI from the ground up, do you think they're going to be more competitive than legacy organizations?
I think probably. I think we obviously like we're a very old company with a lot of legacy products and code, so we're spending a lot of energy thinking about what do you do about brownfield as well as greenfield, right? So we're definitely thinking about that a bunch. I think it's definitely like the most cutting edge folks that I've seen that are like, there are teams in the Valley now that don't look at their code at all, right? Like this is truly like the next layer up the compiler stack. Code is now output, not input. I know teams that are doing that. They're all teams with greenfield projects, like they're small teams that are shipped. But I know a security team, Strong DM, like these guys are very strong proponents of it. Justin McCarthy's really a strong proponent of it. Like they ship a product that is completely agentically built, and they
And
have a
they're
whole
not
system.
actually reading line by line.
He jokes that he would fire anyone who did a code review. What he actually says, I don't want to misquote him or anything, but what he's actually said to me is the only time he looks at code is when the system for him not having to look at code is broken and he needs to fix it.
How do you feel about that? How does Microsoft feel about that?
I mean, I think it's pretty amazing. Like if you want to take that again, the historical perspective, like, here's the history of the computer, industry. Like we started off with circuits, and then we had binary, and then we had assemblers, and then we had low-level languages, and then we had high-level languages, right? That's a stack of abstraction. Every layer in that stack, the next layer up outputs the layer below it, essentially, right? And so like, now we're going up another layer. We're like, we have, spec basically is the input and code is the output. So I don't like, I've been working for 35 something years, in the industry. I started off worrying about whether I was going to be out of date because I was a Pascal programmer and C seemed to be taking over. Like, I've learned that like these worries tend to be kind of irrelevant, and you just like, you should be happy that like the technology is advancing and you can produce stuff. I build stuff with our systems in a week. Like I probably built more stuff this week than my best year ever as a programmer before this. Like I'd be very surprised if that's not literally true. Right. Yeah. So like great, cool. I don't need to deal with code. Like I stopped writing code 15 years ago because I didn't want to deal with code and the details of it anymore. Like I have plenty of ideas. Now I'm building them. My PMs who aren't really technical people are building stuff. Like, it's pretty amazing. I think it's going to radically shift the industry. Like there's no question about it.
So as our relationship with the work changes, how do our skills need to evolve? I'd be curious to get your take on that, both personally, how your own skills have evolved, and then what you would recommend to those folks who are maybe in college right now or just coming out of college. What should they be focused on?
Yeah. Well,
Sam, can you lean forward a bit?
Sorry, I'm trying to lean forward as much as I can. I don't know what's.
We want to make sure we get every word.
It's a Zoom thing or something. So like, first of all, like I think the thing to tell folks that are in college is just like use the tech as much as you can. Like when I was in college, it was the beginning of the PC era, and the old graybeards, which I am one now, like we're mainframe guys, and they were just like, this PC is garbage. Like who cares? It's like this crappy computer. It's not reliable. Don't use it. Blah blah blah. They were totally wrong. Right. Like, the internet showed up, people were like complaining about JavaScript, like I mentioned, like, it's not a real language. You can't build in the browser. It's stupid. Like the best thing to do is just put your hands on stuff and build. Like, that's what kids will do. Like, even if we give them advice, like, they're going to ignore the advice. Like, it's fine. Right. Like, so that's okay. For me personally, I think like the skills that like are really important are kind of system two thinking, like higher level thinking. Right. So like, design, being able to imagine stuff, being able to think through a modular design, being able to be clear about the specification for something. Like, what do you actually want? What do you actually need it to do? That kind of thing. I think those are the skills that matter the most. And so that's kind of what's happening personally. Like I do a lot of thinking about thinking. I do a lot of metacognition now, and think about like, instead of just sitting down and doing something, I think about like, what do I really want to get out of this? How am I organized? Like, do I need a tool to make this work better? Or like, before I start, let me like take a step back and think about what I'm building here and things like that. So like, you're not quite as anxious to just get stuff built. And then like, you don't get attached to code now because it's output. We throw it away if it doesn't work, start over. Like sometimes things don't work and you just like have the system summarize, do a post-mortem, throw the whole thing away, use the postmortem to start over. And like that works really well.
Does code and applications and software in general become more ephemeral? Like, yes, as you said, like you're not getting as attached to it, but there has to be some persistence there. But how do you kind of think about those two conflicting ideas where there's just so much code and it's so easy to generate code in the moment, custom to what you need, yet like the persistence.
There will be persistence, but it'll be persistence of intention in spec, right? I mean, like, you could substitute, we use the word assembly for what you just said, right? Like there is assembly language still in the world, but it just gets output by compilers. It's not really durable. What's durable is the source code today, right? Like, we just regenerate. So the same thing will happen. Like, well, software will, I think, become more transient, lighter weight. I think it'll become more like media. Actually, I think the software industry is going to go through a transformation that's a lot like what the internet did to the media companies, where software gets more specialized, more lightweight, more amateur. It's very, very easy to build small tools and small pieces of experience now. So I think like big monolithic apps, probably don't quite matter as much. I think there's another thing that people haven't really talked much about yet, which is software until now has had essentially, perfect margin economics, right? Like you build it once and it's free to serve forever. That's not true anymore, right? If your software product, if your feature involves inference, it's got an incremental marginal cost. So you better have economic benefit to your users that you can capture somehow, right? So like that, you can't, the era of having like a giant, garbage pile, of features that serve to a billion users and maybe toss random ones on to have certain constituencies like them, is probably, that's probably going to be less effective now, right? Like those
Yeah.
features have to be valuable.
And Sam, I mean, your CEO Satya Nadella said the kind of famous thing, I think it was a little bit over a year ago, where he predicted that the application layer is going to collapse into agents, and effectively you're going to have agents on top of traditional CRUD databases. Do you agree? And like, how far off from that do you think we are? And in that world, really, there is no software; it is just agents.
I think a lot of behavior will go into agents. It's not quite clear what kind of scaffolding you want around them. Like there is some, so yes, in some theoretical sense, I agree with him. I think there's also the pragmatics in the real world. People are slow, change is slow. People like things that are familiar. We do lots of irrational stuff because it's comfortable and familiar to us. So it's a little hard to predict exactly where this stuff comes out. But I do think, yeah, like more and more behavior. For example, like one of the things I do a lot now, I've been building presentations on, the effectiveness of amplifier or, research on the team or business cases or whatever. And I entirely do them in amplifier. And then when I'm done, I just have it generate a single page HTML presentation. It's like a single file that, has navigation inside it. And they look great and they're fantastic. And like those artifacts are, again, output. They're not really, the point was the conversation and the context, not the actual artifact. So like, less and less you need these structured products. But like, I don't know, like I don't think we've completely figured out what the right user experience is yet. This feels still to me a little bit like the early days of the internet, where like all the web pages were green and like weird flashy links and stuff. I don't think we've quite figured out what's comfortable yet.
If you can consider the SaaS business model, which is arguably one of the most successful business models we've seen, over the last 10, 20 years, call it the internet era, you have all of these individual pieces of software that have become like incredibly valuable. Well, it seems like that can't continue, or is it inevitable that there is this consolidation as that application layer is kind of destroyed?
I think what's valuable is going to be more the back ends, right? Like what you want is a playground that you can play in that's safe, right? So you want to be able, I think the ideal thing is you build your own SaaS app for your own custom needs. That's a very easy, fast thing for you to build agentically, but it's safe. And if you get it wrong, you can roll back your data, or, the framework that you're using is careful about compliance for you, or you're sitting on a back end that's careful about compliance for you, or whatever, right? So I think like that's like, if the future of SaaS is definitely not like my expense account system is prettier than your expense account system. Like that, who care? Like those front ends are, that's not a competitive advantage anymore. But like, oh, I have this like really robust back end for expense and accounting, and you can like, people who aren't engineers can like vibe code solutions on top of it, and I can make guarantees to you that you'll never do anything you don't want to do in your business. Like that would be valuable, right?
Are you referring to like the data management layer, essentially the database?
Yeah, I think I call it plumbing, but I think about it as plumbing, right? Like those back ends, the database, like more than just the database. Like I think also the back end services and behaviors and stuff like that. like that scaffolding. But like that's probably like the direction SaaS will start to shift in is, it's very easy to build your own experiences. People are going to want to build their own experiences, so you want to give them safe environments to build them in, safe and compliant environments to build them in. So I think that's probably will happen more and more with SaaS. But if you don't have that need, then you'll just vibe up whatever you need, right? Like
Right.
that's
So changing gears a little bit, it sounds like you're really focused on the future of productivity tools or tooling in general. Like, what are you most excited about for 2026 in that realm?
I mean, I feel like I'm excited by the moment we're in, to be honest. Like, I don't know if that's any one particular thing, but it's really interesting and fun from my perspective to have this new set of capabilities and tools to work with. Like, I really like it. It's sort of poking my programmer OCD pretty massively, and it's really interesting and fun to do that. So like, I'm excited about that. I'm excited to spend the year really figuring out how we make these experiences more approachable. I think that's really interesting. I don't, I think the world of like the models themselves is really interesting right now, right? Like watching the open source stuff kind of catch up to the big foundation labs is interesting. Watching prices continue to come down is really interesting. So that's exciting and fun to watch. But I don't know, right now, like everyone I knew, Karpathy had that thing about feeling overwhelmed. Like every engineer who's really seriously paying attention to this that I know has exactly that feeling. When he posted that, we were all like, "Oh yeah, that's exactly where it is." We're just like, I feel like I'm constantly behind. I feel like I'm constantly overwhelmed. It's exciting, it's fun, but I feel like I'm running in place a lot. So somebody, a couple of days ago said it's like we've been early adopters continually for 3 years, which I think is like a really good way to put it.
Yeah, that's
And
it.
it's really how it feels, right? It's just, and
Yeah.
that's like an exhausting place to be, and like it's not really slowing down. Like we're still early adopters on everything. So, I mean, I'm excited by all of it, but it's work right now. It's like I don't blame people for being kind of exhausted and burned out on it. It's a lot.
Sam, before we let you go, I just have one other question, and we've kind of alluded to it throughout this conversation. Folks being unimpressed with AI, the progress that we're seeing. And so just generally, AI seems to have a little bit of a branding problem. It's something that Matt and I talk about a lot. Once you go outside of this inner sanctum, perspectives change dramatically. And they vary from unimpressed to fearful to outright hatred. I have a friend whose daughter is in film school, and someone on her recent project got wind that she used AI to do some research for her latest film, and he left the project. And that might be an extreme example, but it does seem like there's a branding problem. And do you agree with that? And if so, what's to be done?
I mean, there's definitely a reaction to it. I just spent a whole lot of time thinking about this. Like I said, like I take a kind of historical perspective on a lot of this stuff, right? Like any big transformation, what winds up happening is you get this dichotomy. Like we saw this with GDocs, just to go back to the beginning. Like, you didn't have a lot of in the middle feelings. You either had love it or die in a fire. Like there was never any in between with Google Docs. Like, people like either thought it was amazing and got it and wanted to jump into it, or they just thought we were morons and they just did not want web apps and did not want the cloud and we're never going to trust it. And we heard lots of the same things, like, oh, I'll never trust a company with my files. Like that was the thing we would hear a lot. So like, to me, like a lot of this stuff feels like an echo of that. I mean, I think it's kind of a shame. I wish we weren't getting so much pushback. I think, this transformation, when the internet started, I was a little bit skeptical, and I asked a friend's dad who was a business guy, like, is it real? And he's like, well, I'm pretty sure, like, people really like to communicate, so I'm pretty sure it's real. And I think with AI, like, I would just say the same thing. Like, I'm pretty sure that the thing people like more than even communicating is thinking. And so, like, I think, it's pretty real that, like, we have this tool that does industrializes thinking that's pretty valuable. So like, hopefully it gets to be more people feel like it's more inclusive. I do think it's pretty amazing what's just out there for free right now, like the stuff that people can do and use. So hopefully that value just kind of starts to percolate through. But it is, it's a common pattern when there's disruption, and the stronger the disruption, the stronger the pattern is. So it's not that surprising.
Sam, Thank you so much. This has been great. Love hearing about all the early days. Yeah, thank you. Join the show again. Come back anytime.
Thanks. Sorry about my equipment issues, but thanks for having me.
We'll get
I'll
it. We'll
fix
get it
them
sorted
next
for
time.
next time.
Yeah. Thanks.
Thanks, Sam.
Thanks, Sam. All right.
I mean, I think he's exactly right. Anytime there's a disruptive technology, new, there's always some trepidation, some fear around it. It's kind of the natural course.
Yeah, and I think it's just, of course, amplified by politics and how visible politics is right now, and there's some genuine concerns, of course, and we try to address them on the show, on the channel, and in general. But I think obviously, like, you and I are very optimistic about the future, and we want to help people understand that. We want to help show and shine light on what is possible, and not naively, of course, and address the issues and inequality there. But we are generally quite optimistic.
I would say so. Yeah, with a realistic lens of where things can go wrong, because we do have to be careful about how we do this, how we roll this out.
So we have a little break between now and our next guest. So let's cover some news stories.
Yeah, absolutely. Actually, I have a question for you. Hypothetical. Let's say you had stock in OpenAI, xAI, or Anthropic. Which of the three are you picking?
Yeah, that's a good one. So first, I have shares in none. So this is completely unbiased
and not investment advice.
And very importantly, not investment advice. Thank you, Nick. Yeah. Okay. So I'm going to give the bull case and the bear case for both. And I also want to get your thoughts. So just jump in whenever. First, let's talk about OpenAI. I think OpenAI is ChatGPT is the verb, right? It is. They were kind of the first to market. They they have hundreds and hundreds of millions of users. They are
Uber, the Kleenex of AI.
Exactly. Yeah. And so I think through that lens, really powerful. I also think that they are working on a lot of different products, which could be the bull case, could be the bear case. They're just tackling so many different things. And I'm a huge proponent of focus.
Yeah.
And so that actually leads to Anthropic. And so, like, the bull case for Anthropic is they, first of all, are almost completely catering to the number one use case in artificial intelligence right now, which is what we've been talking about with our last two guests, coding. And they have the frontier models. They have the top model for coding. You can arguably say it's Codex. You can arguably say it's Gemini, but I think a lot of people look at Opus 4.5 and just point to that as the king right now, at least. And so they are entirely focused on that. They are not getting distracted by other products, consumers, frankly. And so it's really powerful. Plus, they are, I believe, on track to being profitable, and they generate a ton of revenue, and so that's all good. Now, the bear case is if you're putting all your eggs in one basket, and that basket ends up being saturated by your competitors, then that's certainly going to be a problem. It might be a race to the bottom on pricing, and they're not addressing consumers. So there's that. And then xAI, we didn't talk about Google, and maybe you can share why, but for xAI, it's all about Elon and his vision and just his ability to inspire his team to break through barriers that previously were thought impossible, whether you're talking about building incredible data centers in less than 18 months and basically starting from zero and having a frontier model in the course of under 2 years. These are incredible things. And I think, Peter Thiel said, never bet against Elon. I think the kind of flip side, the bear case for xAI is I don't think they're known for having the frontier model, the top tier model at any given time. I know Elon posts frequently about, hey, look at this, one data point in which Grok and xAI is the best. But generally, at least, from my network, I'm just not hearing usage of Grok consistently for enterprise use cases, a little bit more for consumer.
Great summary. So put simply, OpenAI, we have scale, distribution as pros. We also have, and this could be a bull case or a bear case, but how many areas they're focused on. Anthropic, enterprise, extreme focus, double-edged sword though. And then XAI, don't bet against Elon. They've made incredible progress. They've been the last to enter the market of those three companies, and they're arguably right at the frontier, but not quite.
And it's interesting because all three of these companies that we're talking about do not have cash cows like Google.
Well, that's why Google was left off, my question, frankly, and Microsoft. Microsoft probably doesn't, maybe, but both of them are out because they have abilities to fund their AI efforts without taking on additional financing.
That seems like the risk for OpenAI. You know, when you have so many different things, whether you're building a consumer product with Johnny Ive, or you have ChatGPT for consumers, you have ChatGPT for business, you also have Codex for coding. Now you have ChatGPT Health. I mean, they have image generation, video generation. They have a social network with Sora. I mean, the list goes on, and they're building so many cool things. And by the way, they're shipping like crazy. So not taking anything away from them, but they're funding all of this with investment, and it's not from another business line that is able to generate just massive mounds of cash like a Google search, right? So I feel, and maybe this is my more conservative economic posturing inside of a company, it just feels like it's a bit spreading yourself too thin.
So I got a great summary out of you, but I didn't get an answer.
I think I would still bet on OpenAI.
Okay.
There's just I go back to ChatGPT. That's the one I open on my phone when I have a question. That's the one that I just frequently go to for help. There are certainly use cases I go to Grok for. There are certainly use cases I'm going to Anthropic, especially coding. But for my day-to-day, that's what I use it for. And then I also think they will continue to be able to garner investment and making all of these bets seen both through kind of the pessimistic and optimistic lens. I'm like pretty excited about a lot of these different things. And if one of them, 2, 3 of them work incredibly well, those are entire business lines. Those are, potentially multi-$100 billion businesses.
Yeah. I can't disagree. It's also my daily driver. So, and I want to actually get to another question, but we should talk about ChatGPT Health, which just was released.
Yeah,
another one of those business lines. But before we get to that, Alex, can you pull up my screen? I want to share Polymarket's predictions. So this is which company has best AI model by the end of June. Does this surprise you at all? How lopsided it is?
Who's number one? Google.
This is
right?
Google, yeah.
Yeah, I mean, I think it's by the way, this stuff, like, it flips all the time. So
it does flip.
The second some other news comes out or some insider has some news, like June might as well be 20 years from now. So like, take all of this with a grain of salt. But I think this is probably more of a reflection of where we are currently. Gemini is a fantastic model. Google has a lot of tricks up their sleeve. And what is this based on? Is this, which benchmark is this, or kind of which leaderboard?
That's a great question.
Because usually at the bottom, look at all these.
Can
you go to the show more right there? Let's see, Ella Marina. Okay,
yeah, Ella Marina.
So Ella Marina is, correct me if I'm wrong, based on ELO score, which is based on human voting.
Yep, that's right.
Yeah. So I don't know. Yeah.
We're to your point, we're bound to see a lot of variance in this over the coming months.
Surprised to see XAI number 2.
Yeah.
And OpenAI, coming in at 8%, single digit percentages. And so we're really talking about almost the vibe of the model. We're not talking about benchmarks. This is a leaderboard. This is ELO.
Personal preference.
personal preference, voting, human voting. And,
Yeah.
do you remember there was that, quote unquote scandal with Llama when I think it was Llama 4 came out. They like optimized it for the Ella Marina leaderboard. I think they kind of found out. Correct me if I'm wrong. There was like, if you add more emojis to the answer, you're going to get a higher score, or
that sounds right.
higher vote, higher win
Yeah.
percentage. So there's just ways to game it.
Yeah.
I wish we had a better way to measure how good these models are. I know we have a ton of benchmarks. We have the leaderboards, but I just feel like there is still something missing where we can definitively say this is the best model on the planet right now. And I guess it really does depend on whatever use case you're applying it to.
Yeah. Speaking of, we have to get Greg on the show from Arc Prize. We'd love to get his perspective on where this is headed in 2026.
Yeah, absolutely.
All right. Let's cover one more story here. And that's ChatGPT Health. So this is a dedicated space for health conversations in ChatGPT. Now, I know you just downloaded it, haven't had a lot of time to play around with it yet. What are your initial reactions?
I just got access. First of all, I asked OpenAI for early access, and they gave me a hard no. They did not give preferential access to anybody, or at least that's what I was told. But I did get access just about an hour ago, right before the show started. So I haven't had a chance to play around with it. I opened it up. There's nothing to download. It just appears in ChatGPT. Yeah. Opened it up. It asked for first name, last name, and birthday. And then it went off and searched health providers that I might be connected with. And it had a decent list, 8 to 10. I don't think I had heard of most of them. And it was where I previously lived. So I don't know where they're getting that data from. And then it just like, the process to connect my health data, and let's come back to whether you would be comfortable or not doing that, but just the process seemed ripe with friction. And so I'm going to certainly like try to get it done. And I want to play around with it. I'm excited about it. But just that like initial process, I didn't even have time to finish, and it felt like it was going to be a project in itself. So I want to pause there and we should talk about whether I want to hear, Nick, would you be comfortable sharing your health data with ChatGPT and OpenAI?
I'm really split on this right now. I was one of the people who did the DNA sampling, 23andMe, and I did it without really even thinking about it, right? And kind of regret being so flippant about it. I don't necessarily regret doing it, but I regret my approach to it. Should have been more thoughtful. Giving away stuff that is so personal comes with a lot of implications. Now, that said, and I'm going to go back to the brand problem that AI has, because I know I'm a broken record here, but I really believe that this is actually how we fix it. Because so much of the narrative right now is creating godlike intelligence, creating super intelligence. This stuff is going to be so much smarter than you, and it's going to take your job. It's going to do your job better. Like, that narrative needs to stop, and we need to start focusing on practicality. Okay, you can have a world-class doctor in your pocket. Everyone knows our healthcare system isn't set up ideally. It takes a long time to speak to a doctor. It takes a long time to get into an appointment. If you have all the world's knowledge and your personal context built into that knowledge, suddenly this becomes highly valuable. And so I really see the potential of something like this. And so I'm intrigued and considering it.
So let's look at this in a vacuum. Let's say privacy and security solved, and all of a sudden, like, what is the actual utility? What is the actual value? And I think it is massive. I am incredibly excited about this. I already, whenever I get test results back from the doctor, scans, the first thing I do before I speak to the human doctor is I upload everything and I say, just explain what you're seeing here. And that is not a replacement for the human doctor. That is strictly so I show up more informed when I speak to my doctor, and being able to ask questions in the moment. I mean, just a few years ago, I would get results back from a scan and I would look at it and I would, what am I even looking at here? And now I just have ChatGPT explain it to me. So I love that. And then when it really becomes powerful is when it's proactive, when it's able to actually say, oh, hey, I see kind of a simple example. You haven't had a physical this year. You should probably book one. Do you want me to do that for you?
You haven't
Or,
been to the dentist in 5 years. It's time to go.
all right. Are you saying I have stinky breath or what? So I think there's something really powerful there. Or like, hey, in your last blood test, which was 2 years ago, this kind of level of something was elevated, and you need to take a look and probably check in on that again. I don't get that at all from my current health system or doctor. It is completely reactive. I have to go ask them for help. I have to be kind of pulling them to help me versus proactively helping. And then we get into the entire world of preventative medicine, which is like, or that's kind of the holy grail for our health system, rather than just reacting and prescribing medicine and going to the doctor. Like, what can we do beforehand? How can we change our eating habits? How can we change our sleeping habits, our exercise? What are little things? And then all of a sudden you have this private professional coach that can help with that. And custom, right? Hyper customized to me specifically and you specifically. I'm so excited about that.
Yeah, I think that's really well said. And I want to double tap into something you just said about proactivity. So this is one of the fundamental problems with the healthcare system is you have to be extremely proactive about your health, which means you need to know not only what's going on with your results, but you need to know what questions to ask about those results.
Yeah.
And so if you have an aide or an assistant in your pocket that can help guide your conversations with a healthcare professional once you end up talking to them, that alone is invaluable. So yeah, I agree. I'm also really excited about this. And helping people in this way, again, is going to change the narrative.
Yeah. Our next guest is here. I think we bring him on.
Let's bring him on. So good friend of Forward Future. Our last guest, we have Andrew Feldman. He is the founder and CEO of Cerebras. Now, he's going to talk all about this, but this company took a very radical approach to building AI infrastructure. The rest of the industry was scaling by stitching together more and more chips. Andrew and his team took a completely different approach and bet on an exceptionally large single chip. And we're going to talk all about it. Andrew, welcome to the show.
Hey guys, thanks for having me.
Good to see you again.
Well, last time we saw you, we were eating some delicious barbecue outside of your Oklahoma City data center.
We do have a preference for barbecue. We have some barbecue pits here in our Sunnyvale office, and aren't afraid to do a little barbecue when we open a new facility.
It seems only fitting.
Give us a little update. So we visited you during your grand opening at the new data center in Oklahoma. That was 4 months ago, 3 months ago or so. Give us some updates since then.
Yeah, it has been an extraordinary run for us. We continue to deliver the fastest inference across models in the world. And that's sort of an exciting thing to be able to say and to say it without qualification. And so business is going well. We've opened additional data centers. We opened a facility in Montreal, Canada. We have additional facilities around the globe that are being what are called fit out in preparation for deployments. You know, it is an extraordinary time to be in AI hardware. I mean, the demand is extraordinary. The things people are doing with the hardware is amazing. And we've seen people create video games with, a simple prompt, create Space Invaders, put it in an HTML file, and literally 3 seconds. 3 seconds later, you got a working video game. Particularly in coding and in the broader range of applications. Speed is everything right now, and it's phenomenal to see.
Andrew, it's nice to be able to talk to a fellow speed maxi because I've been talking about this for a while, and that doesn't mean sacrifice quality, but I feel like the perception around how important speed is has been changing, at least, especially in the last only like month, 2 months.
Oh, for
It
sure.
just seems like something has been changing and people are really understanding how important speed is.
Well, I think you're right. I think if you look at history and you say that, uh, when the internet was slow, Netflix was delivering DVDs in envelopes, right? And when the internet got fast, they became a movie studio. And you just stop and you think about what that means, right? That it didn't make them 5 times faster or more efficient at DVD shipping in envelopes. It enabled them to become something completely different and maybe unthinkable at the time they started the company. That's what speed does in infrastructure. It unlocks a whole collection of opportunities and ideas that are otherwise foreclosed. And what we're seeing as we look out there is that these reasoning models are so smart, but if run on GPUs takes so much time to provide a good answer, and when run on us are so blisteringly fast, that there's a sort of an emotional response to being engaged with it. Somebody tweeted that running one of our partners' code on us, running cognition code on Cerebras, and working with their tool was like touching God. And I was like, whoa. What a nice thing to say about your hardware software combination, right?
Quite the endorsement, yeah.
Yeah, and we were so proud that people feel tangibly sort of the benefit of all the hard work we put in to build this speed.
Yeah. What was the light bulb moment way back in the day when you were just getting started that, bigger was going to be the better route?
Yeah. So, in many parts of chip building, bigger is a disaster, right? I mean, you don't want a bigger cell phone part. You want a smaller cell phone part. In many, many parts of the compute world, what you want is smaller. But what we saw in 2015 was that AI presented some really unusual challenges to the underlying compute engine. And in particular, inference required you to go to memory and move weights to compute to generate every single word. Every token required this sort of extraordinary movement from memory to compute. And you think, well, hey, how hard is it to move from memory to compute? Let's just think of a 70 billion parameter model, a small model. Each of those 70 billion parameter weights is 16 bits. That's 140 gigabytes of data has to move from memory to compute to generate one word.
Every time.
Every time.
Yeah.
How big is 140 gigabytes? It's 100 full-length movies.
Wow.
So you're moving 100 full-length movies from memory to compute to generate a word. And you'd like your response to be 1,000 words deep. We looked at that and said, holy crap, what would happen if we focused all our attention on making the link between the memory and the compute? What if we made it 5,000 times faster than a GPU? And to do that, we put the memory and the compute on the same piece of silicon. We located the memory and the compute adjacent to each other. And once you have that insight, you want to build a big chip. You want to get as much memory and as much compute on a single die as you can. And what we ended up with is a chip the size of a dinner plate. This is our 3rd generation part. It's a 5 nanometer chip, and it's 56 times larger than Rubin. 56 times larger than the largest chip NVIDIA's ever produced.
All right.
Yeah.
So
we both held this thing, by the way, Matt. And
Yeah, I
I'm not
remember.
going to say I felt godlike, but I certainly felt powerful.
Yeah, it's okay if you felt angel-like. You don't have to go to the big
Sure,
man,
sure.
right? We can.
so look, obviously, like the biggest news in the last couple of weeks was Nvidia's acquisition of Grok, and I want to talk to you about it because you're the perfect person to lend some perspective. What do you think Nvidia realized? What do you think was the rationale behind kind of doing this? I'm going to call it an acquisition. We'll get to
It's an
what it
acquisition.
actually.
No,
Yeah, like
it's-
what was what did they see? What are they trying to fulfill in their strategy?
I think what they saw was that the GPU architecture couldn't do fast inference. And I think one of the sort of leading Wall Street guys pinged me immediately afterwards, and he said, "Congratulations."
Mm.
And I said, well, thank you. He said, the biggest moat around NVIDIA's got nothing to do with technology. It's a mental moat. It's a mental view that all you need to do AI is NVIDIA. And
So
by
you don't even think
spending,
it's software?
yeah, that's right. It's not. You don't need any NVIDIA software to do inference. None.
Why do people talk about CUDA as if it is like the ultimate moat?
Because they misunderstand. They fundamentally misunderstand what is at the heart of the advantage. I think CUDA in 2015 and 16 and 17 and 18 was a big moat. But right now, it's 11 keystrokes to move from running on GPUs to running on our cloud, on our infrastructure. 11 keystrokes to move your entire workload to us to do inference.
So I want to get your thoughts on a couple of things. I think like a lot of people are saying this is kind of the admittance of
Yes.
the move from training to inference, and inference is where the revenue is going to be. Is that your perception as well? And then also talk about that within the context of Cerebras, because that is where Cerebras owns
is orders of magnitude faster than everybody else. So let's think about this, right? The simplest way to understand our space is to say you make AI with training and you use AI with inference. And the thing about using AI is the amount of use will grow with the number of people using times the frequency with which they use. And you multiply that by how big a model or how much compute each use takes. And what we're seeing is more people adopt it. We're seeing them use it more often, and they're using bigger models, which take more compute. And that is what's fueling this extraordinary explosion of inference demand. When we go from hundreds of millions to billions of users, when we go from once a week to once a day, when we go from once a day to 5 times a day or 20 times a day, when we go from models that are 30 billion parameters to 70 billion to 120 billion to 400 billion to a trillion, right? Those are geometric expansions on 3 different vectors: the number of users, the frequency of use, and the compute. All of them are growing extraordinarily quickly. And so not only was it an admission that the world will be dominated, or the compute landscape will be dominated by inference, but that the GPU needed help. It wasn't enough. It couldn't do fast inference. And it couldn't do fast inference for exactly the answer to Nick's question about why we started the company, is because HBM is far away and slow in moving data from memory to compute. And you can't get around that. And so that's the fundamental sort of observation they made. I think some of our success, some of the TPU success also drove them to that conclusion. But I think it is $20 billion is a lot of money, even for one of the great companies of our era, Nvidia. You don't spend that flippantly,
Yeah.
right? That's not a $100 million flyer. That's an admission that what you have in your portfolio isn't going to get the job done.
Do you think it's fair to say that the GPU era was simply a transitional phase, or will there always be room in the market for a GPU instead of moving completely to the ASICs?
I think there's even room for GPUs in inference. There is a portion of the market that doesn't care about speed, right? For example, batch work, generating data. Those are things that you're perfectly happy to have it run overnight and come back with a huge output. That's not the interesting part. That's not the reasoning part. That's not the agentic flows. That's not the real-time, the engagement part. But there is a value there. And there's clearly value in training. And there's value in HPC. And there's value in a bunch of other domains. But I think what you will see is that fast inference is a huge chunk of the training market and the most valuable part, and that is not a place where the GPU will win.
You talked about HBM. You've obviously seen memory prices just absolutely skyrocket,
Through the roof.
I mean it's insane, and people can't get enough. How does that affect the kind of broader GPU market? But then also, like, how does that affect Cerebras?
We don't use it, so it benefits us, right? I mean, if other people are paying more, if other people are waiting 6, 9, 12, or 15 months to get a part that is needed to make their GPUs valuable, that is obviously a benefit to us. We don't use it. We are unaffected.
Do you have a prediction on how long that effect is going to impact the industry outside of Cerebras?
Okay, I don't, other than to say I don't. If you want a good way to make a little money, begin with a big money and try and forecast the DRAM market, right? The DRAM market has historically been extraordinarily capricious and been really easy to lose a ton of money trying to bet on or against DRAM. But that said, in this particular case, we know people are buying out through 26 into 27. This isn't some sort of product transition or some traditional cycle. This is demand outstripping supply. And whether it's Hynix or Samsung or Micron, we know what their fab capacity is, and we know the demand, and there's an imbalance right now by a lot. And so that will last for quite some time.
Yeah. I want to ask you one last question on the acquisition. How do you feel about the structure of the deal? I mean, we've seen this like with Scale AI, with Windsurf, where they leave kind of the shell of a company, but they acquire the IP, they acquire all the top people. It's not truly an acquisition. I think the reason is to avoid, competitive issues and monopolistic regulation. Like, what do you think about that?
Well, obviously, this is an acquisition. There is retention money for the employees. 90% of the people moved to the acquiring entity. That's not a licensing deal, right? Licensing deals don't come with an entire engineering team and 90% of the company. They don't come with large retention packages for those who move. What that is that's an effort to sidestep regulation and oversight.
Is that even necessary anymore in the current administration? Or is it just like, hey, it's faster. We're going to get it done more quickly.
Clearly, that was on their mind. I think now the downside of that is for shareholders, there are a ton of taxes to pay. There's no long-term capital gains tax on a deal like this. You have to run it through the corporate balance sheet. So there's corporate taxes to pay at 32%. And so investors get a great deal less money than they would otherwise. But this is not just this one, but across the board. These are acquisitions via a new mechanism.
Do you think it's going to be good for the industry or no?
Um, I think the amount of oversight and the challenges in getting deals done was bad for the industry.
Yeah.
I think what would be best would be sort of less oversight, where it's there more thoughtful, and going back to doing simple deals that everybody understands correctly. Right? The answer isn't to itch your ear like this, right? That's not the answer. I mean, let's our ear itches, let's go the most direct path. And the right way to do it is sort of thoughtful regulation, less of it, to actually cover the cases that are designed to be covered, rather than sort of months of bureaucratic mess in trying to get an acquisition done.
Go ahead, Nick.
Yeah, I want to transition to power and electricity. So I think I've heard you say that we have enough power. It's just in the wrong places.
We do.
Can you explain what that means?
Well, we have a tremendous amount of the resources necessary to make power. But we underinvested for 50 years in our grid. And much of this power that we have, or the potential power, is in places that people don't live, and people haven't invested in either the grid or in the fiber optics necessary to take data from a data center that uses the power and put it into connect it with people. So we have a ton of power up in Niagara. It's a long way away from people. We have power in the Permian Basin. We have power in Wyoming. We have power in all of this is natural gas power, except some falling water, right? Some hydro. But what we haven't had is investment in the grid that could take advantage of this power. And so now people, where there are holes in the ecosystem, people jump in and are going behind the meter. And what that means is they're basically making little power plants on site to power their data centers. They're taking the natural gas and burning it in generators and using those generators to create electricity, which then powers the data center. And I think that there is a frustrating patchwork of regulation across the country for building out these data centers. These local property regulations are brutal to manage. I think, as an industry, we might not have done a very good job in working with communities to be sure they understand what's being put down. These are big buildings. They're loud. They create a large number of construction jobs and then a modest number of jobs on site. I think had we thought more carefully and collaborated more carefully with some of these communities, it wasn't taken advantage of for industrial applications like building data centers.
It seemed like last year we saw a resurgence of nuclear too. Do you think that's effectively inevitable, or?
I do. I think nuclear is some of the cleanest and lowest cost power we know how to make. It has an upfront cost, which is higher than natural gas, but over a 20 or 30-year period, it is much more cost efficient. And I think as it was developed into the 70s, we became afraid. I think that was maybe appropriate at the time, but now with the benefit of hindsight and some careful management, it is one of the cleaner and certainly cheaper ways to make power. And I think you are certainly seeing now that the entrepreneurial ecosystem has a shot at it, rather than just GE or some of these giant companies. You're seeing small form factor nuclear reactors. You're seeing all sorts of interesting approaches to low cost, extremely safe nuclear power. And I think that's really exciting.
Andrew, that I think that is perfect. Let's talk about the Genesis mission you're a part of. First of all, what is it, and give us a little bit about it.
Sure. I think one way to think about it is that our administration came to believe that we needed a sort of Manhattan Project for AI, and that the government needed to get its act together, get the various different parts of the sprawling federal government together, and agree that this was important, that we would put resources on it, that there would be a collaboration, there would be investment, that they would try and catalyze entrepreneurship. They would try and collaborate with the bigger companies in the pursuit of sort of not incremental benefit from AI, but step function change. Can we radically improve the rate of scientific progress? Can we fundamentally improve the US security posture through the use of AI? And this is being led out of the Department of Energy. Remember, the Department of Energy, not only do they look after our nuclear arsenal, but they also have the largest government-owned supercomputers. And so this was a natural place for this to be housed. And they have gathered leaders from across the national labs and across industry to come together. I met with the secretary, with a collection of industry leaders, with Jensen and with Lisa, with leaders from OpenAI and Anthropic, among others. And the idea is, can we take disparate ideas and create a mission, right? Can we take all the different things the government's doing? Can we squash some of the dumb things, some of the things in the way? And can we focus energy together on using AI to advantage the US and its people? And that's it's sort of fun to be part of a mission like that, right? And it's exciting. It gets your blood going. I mean, we become engineers to solve really hard problems that benefit people, right? That's why we do this. And when you have a chance to do this at a national level, to have your technology used by the world's leading scientists to benefit the U.S. as a nation, it's something that makes you proud every day.
That's so cool. And earlier, we were talking about the perception problem with artificial intelligence. How do you get people, the kind of more broad public in the United States and then in the world, to get excited about the Genesis mission?
I think we had a GPT moment in 2023. And before that, we had sort of a moment in which we agreed tacitly on a dominant design, transformers. So 2018, I think the paper came out, 2019. The industry tried a bunch of things and we sort of resolved around the transformer design. We had our GPT moment where everybody said, whoa, this is cool. And then it's taken 2 or 3 years for everyone to say, whoa, this is useful. And that's where we are now. And that's why people are using it to write code. That there are AI agents being developed that can sift through literature and create hypotheses, and then go out and see if the hypothesis is answered in other literature. I think that the way you convince people of real technology benefit is not with good marketing. It's by showing them how it impacts their lives and how it impacts their work, how it eliminates some of the bullshit they do every day at work. I mean, I don't know about you guys, but the amount of time that is lost in a company moving data from ServiceNow to Salesforce or vice versa, or from one app to another, right? From your ERP to your payroll. The amount of opportunity there is, not even to do great things, but to eliminate bullshit is extraordinary. And imagine if you just got a couple hours back a day for a workforce of 80 million, 60 million, right? Imagine what that does to labor unit productivity. And so I think I'm excited both about the big and the small, right? The ability of AI to eliminate mundane and the frustrating things in work, as well as its ability to do some stuff that's eye-popping. And so I think that's how the world comes to see it. Just like I think, how did the world come to see payments are best done by phone? Well, you have a lot of Indian farmers who were able to not have bank accounts, to be semi-literate, and can work on their phone and transact business. It became useful. And that's how, Tencent's WeChat, how their payment structure is working in China. You make things that are unbelievably useful, and they start in a key demographic. But by the end, your dad who's in his 80s or 90s is using it, and children are using it.
So usefulness solves all perception problems.
I believe so.
Yeah.
I believe so.
Well, Andrew, I want to say thank you so much for joining us today. Always a pleasure. I can't wait to get the next tour, and please come back again on the show.
We have more data centers coming up, and we'd love to have you out. Nick and Matt, thank you so much for inviting me to your show. I very much appreciate it.
All right. Thank you, Andrew.
All right, be well, guys. Happy New Year.
Happy New Year. All right. And that's our show, Nick. Fun. I want to thank our guests, Ioannis from Reflection AI. I want to thank Sam from Microsoft, and of course, Andrew from Cerebras. Nick, thank you so much for co-hosting with me once again.
Feels good to be back. Let's do it again next week.
Yeah, absolutely. Don't forget to follow us on Twitter or X @ForwardFuture. Check out our newsletter, forwardfuture.ai, and we'll see you next week.